Record. Okay, we're gonna do a bunch of stuff with strings today. So string methods, file IO, and then we're gonna talk about DocString testing. So again, the name of the game today is going to be working with strings. Just some housekeeping before we begin. Good news. You don't have to see me again after this-ish. So the next module on object-oriented programming will start next week. So I'm going to hand over to Azada. She's a great instructor. I think she's coming from us from Deakin. So she's going to take you from next week all the way to the penultimate week. So I'm going to be back here at week 13 to teach you about recursion, which is pretty cool, right? So no more me after this week. So I'll miss you guys, I guess. Okay, you have an inter-semester examination this Saturday. I hope this isn't a big surprise to anyone, but good luck on it. Don't try to rush this. Like, you're going to have adequate time. I think you have to think. So don't race. Don't try to race through this exam. You're going to make mistakes. You have to be thoughtful about this. Now, when I first came to Australia, they provisioned something here, which I actually convinced people back in Canada to start doing. And it's this 10 minutes of time before the exam starts where you're, what is it called? Review? Does anyone know what the terminology for this is? Perusal. I love this notion of perusal. So for the first 10 minutes of the exam, you're supposed to peruse the exam. That is to say, read it. Read the exam. Now, students agitated so much that you used to be barred from writing during the perusal phase, which was appropriate because there's like good scientific literature saying that if you read the test first comprehensively before starting, you will do better. Your brain is going to subconsciously work on the problems that you've loaded, right? So I want you to use your perusal for perusal. Take 10 minutes and read the exam from front to back before starting anything. It's going to help you. You don't have to rush. Rushing is going to screw you, right? Little mistakes in our industry aren't little. There's no such things as little mistakes. Okay. Do you know what box breathing is? So box breathing, it's like you imagine fours around a box. You breathe in for 4 seconds, you hold it for 4 seconds, you breathe out for 4 seconds, and then you repeat that. I want you to do this every half hour. You need to bring down your vasovagal system, your anxious system, right? And you can do that through breathing. Well, breathing can also make you less anxious, but that's for another day. Okay, but I don't want you to be stressed while doing this, right? So you should utilize known strategies for making you less stressed out. I want you to be in the correct state of mind. And that being said, like, good luck. And don't forget, if there's 2 grading schemes for the inter-semester. If you really do poorly on it, we'll really turn down the weighting in the final grade calculation. So you'll get to make it up if you really do have a whoopsie on it, right? So try not to be overly stressed. I also want to remind everyone that there's a help center like 100 meters from here that's being not utilized at all. So right now you could have personal tutoring from one of my course staff for literal hours for free because no one is utilizing that resource. So if you just walk into the general purpose building 78, as soon as you walk in the door to your left, you'll see a giant help. The engineers are using it a lot. So I encourage you to go, just even if you don't want to utilize the course staff, just utilize that room for studying. Because then if you get stuck, you can just walk over to a staff member, and ask a question and get unstuck, right? I want you to be productive in your studying. Okay, third, if you don't want to listen to any of that and intend on not doing any work, I'll remind you that if the Maple Leafs win the Stanley Cup, I'll be so happy that everyone in this course is going to get a 7, with some caveats. The Leafs actually have to win, and they have to win before your final exam. Just so you know, the Maple Leafs are cursed. They haven't won the cup since 1967, but they are still in the competition, so it's technically possible. And I really do feel like this year is our year. Okay, so enough of that. So what we're going to do today is talk about first file processing. Well, no, we're not. I didn't want to talk about sorry. Because we are going to be doing file processing today, and because in general, any I/O interaction we have with a user is going to be strings. Like, remember, a user can never type in a number into the system. They can only type strings. We want to be able to process strings simply. And in order to do this, we want to utilize something called a string method. Now, methods are going to become more explainable to you once you understand what an object is. So for today, we're just going to sort of put that aside. But I want you to know that every string method that we're going to utilize today, or any string method that's in the system, you should be able to program yourself, right? So you should only really use these string methods after programming it yourself once, right? And then you get to ignore it. The problem with Python, or one of the problems for using it for teaching, is that it's so fully featured that it's actually difficult to ask the class to do anything simple, because you can just go find the string method that implements it. But so is life. Okay, so there are a myriad of built-in string methods in Python. You can review them by searching the web or just typing help string. So if I type help string, it's going to print off something really long. So I'm just going to go into here, go into Python and type help on string. And you see this is all the informations about strings. And since strings are like an exceptionally important primitive data type in the system, it's no mystery why this is so long. But starting here, you can see all of the methods that strings provide. So for example, there's a capitalize method, there's a case fold method, a centering method, a counting method, and a lot more than that. I don't know why it's scrolling so slowly. Okay, something's wrong with my REPL, but in any case, you can see there are tons and tons and tons and tons of these string methods. If you want to do something with a string, probably it is already the case that the string method exists. Okay, so we're eventually going to learn that strings are objects. That's going to happen next week. And objects have, instead of having, so what we've been doing is defining functions and then giving input to those functions and getting output back. We're going to now soon switch to a different philosophy where you have an object which have methods, and those methods are have a different style of invocation. So for example, whereas in imperative programming, we would write a function capitalize that takes in something like hello and returns back that version capitalized. Methods are actually have this invocation style. We say, here's a string. This string has access to all of these string methods down here. And the way that we access the method is by using this dot and then saying what the function or the method name is. So it's not capitalized hello, right, which is passing a function, a input, but it's saying this string has this method called capitalize, which I want to run. And these braces are important, right, because these are actions being performed, right? So this basically is saying do something, right? So I can say hello.capitalize and get that hello back. So I can do that in the REPL as well. So I can say, here's hello. It has a string method for capitalization, capitalize, the correct spelling, and it will do that. Okay, so far so good. But just note that it's a different invocation style. This is a function call. This is a method call. You're going to be writing methods quite soon. Okay, so for information on particular methods, you can always say, okay, give me help not on string in totality, but give me help on string and its specific method find. Okay, so it's going to spit out something like this. You need to be able to read the documentation. Do anyone know the acronym RTFM? You may get, if you ask, asking questions of other computer scientists can be tough because other computer scientists are mean. But sometimes if you ask a question on Stack Exchange, they'll just respond RTFM, that is read the friggin' manual. Right? So a lot of times they'll say, hey, this information can actually be deduced if you read the documentation that we very carefully put together for everyone. So do make sure you read the documentation before asking senior engineers about something, because they may get a little bit cranky. Now, because you need to be able to read documentation, I need to teach you how to read this documentation because it can get kind of tricky. So here's what you would see. And it's often the case that on the exam or the midterm, I'll say something like, here's the documentation for a function or a method, use it. Right, just to check that you can read. Actually, one of your EdSTEM problems is actually, one of the dictionary problems is, here's a description of a method and utilize it. So here we're saying, here's the method for find. You're going to call it, so S is going to be a string. You call it by saying dot find, and then this is the sort of arguments that find is expecting. Things in square brackets are optional. So this says, okay, you need, in order to, on this string called the method find, You have to give me this sub input, but it's optional to give me this start input. And further, it's optional to give me this end input, right? So this is anything in braces is optional, but the thing that can happen is that optional parameters can have more optional parameters. So this sort of recurses. This is saying this has to be here and optionally this. And if you select for this optionally to be here, then start has to be in it and then optionally end. Okay, so what are the comprehensive ways that we can call this? So I can say we can find I in team or not find it. This is an appropriate call because I had to say what sub was. That was required. I can say find I in team starting at 1. That's also okay because I've given this mandatory parameter and this optional parameter. I can also say find I in team. Find I, the non-optional parameter, in team, starting at the optional index 1, ending at the optional index -1. So this is also okay to be called. But find 1 -1 is not allowed because this first parameter was required. It is not optional. Okay, so the learning objective here is that when you're reading documentations, anything in a square bracket is considered optional argument. And these optional arguments can have optional argument. So given that we just read let's read through what this does. So if we find something in a string, if we utilize that string method, we're going to return the lowest index in S where the substring sub is found. Okay, so let's see. I go back to here. What is this going to do? We read the documentation. It's going to give us the least index where we can find world, but we're going to start looking at index 6. What is this going to return? So let's return 6. 0, 1, 2, 3, 4, 5, 6. Okay, so can we find world starting at 6? Yes, we can. It's at 6. Can we find hello in hello, hello? Okay, so what index, at which index do we find hello? Yeah. Why did you say 0? Pardon me? Well, it starts at 0, but isn't there another 0? Isn't there another hello here? Okay, so you're saying this one's here and it's first, so let's pick it. But why? Pardon me? That is the correct answer, though. But like, if I gave you this on an exam, like you would be stressed because you wouldn't know if hello is finding the first instance of hello or the second instance of hello. So how do we reconcile this? Yeah. Yeah, how did you know that, though? Exactly. It's in here. In order to know if it finds the first one or the second one, you have to read the documentation because I don't know. How did they implement it? In this one, it says it returns the lowest index. So that's how we know that this one returns 0 and not 6, right? Because that's what the documentation said. We could have had another find could have been implemented to give you the last index, right? Both would be fine, but we just have to designate that somewhere. What about this? Hello, hello, if I start at 1. Right now, that's going to find the second one because it can't find a substring hello until substring 6. What about hello, hello, find hello, starting at index 1 and finishing at 3? Yeah. -1. And how did you know that? Because in the DocString, if you look back here, it says return -1 on failure. Right. So because remember, we're in a system where effectively we're allowed to do anything. Right. So when functions didn't have appropriate output, we had some options. We could have said return garbage. Just assume that like you're not allowed to call a function where a substring doesn't exist. We could have a precondition. Another option was to return none. And another option was just to return a default value. But if we're returning default values on methods, how are we supposed to know that default method? And the answer is it's going to be listed in the documentation, which is why we've been so adamant that you guys are writing docstrings and stuff like this, because it's important. Because it's not always clear what something should be doing. Okay, so the following may be accomplished by invoking the appropriate string method correctly. So convert a string of text into title format. So do you think that we could solve this problem by like utilizing a string method? What do you suppose such a string method may be called? Like this is the perfect candidate for like looking at a problem and being like, oh, this probably has already been solved. Yes, sir. Dot title. So let's see. We'll go into here. Oops. So I don't know. Usually I can scroll through this a lot faster than this. I don't understand what's happening. Okay, but I do know there's something called string.title. Okay, so you say return a version of the string where each word is title case. That seems like what we want. More specifically, words that start with uppercase characters and all remaining case characters have lowercase. So let's see. I can say a tale of two cities, and I can say title case that, and we get that back. Cool. Just be forewarned, like I could then say on it, I think on one of your practice midterms, actually, I said implement this, but you're not allowed to use the title. Right. So always be careful. I'm always allowed, and I in fact often do say, this is a method that we've been using a lot, implement it without using the method itself. So do ensure that you could implement at least once any of the methods that you're using. Yes, sir. Dot upper and for the individual characters? Yeah, why not? But then you should also be able to implement those, right? So you should know, we should be able to do all of this without methods. But I'm saying now that we're going to do string processing, we'll use the methods because otherwise our code is going to get so huge. And that's sort of what you need to do. If your code gets too bloated, you need to look at it and ask, is there any of these things that I could abstract away in such a manner to clamp down on code duplication and stuff like that. Write a function that, given a word and an integer width, centers the word in a sequence of x's. The reason I put this here is because this was actually something that the students had to do maybe 3 years ago on one of their assessments. And it turns out such a method did exist. They just sort of had to find it. So this is just sort of putting the word spam in the middle of a field and then decorating it a bit. So there turns out we can find the string method for center, and we read it and we say, oh, return a centered string of length width. That's pretty good, but we were filling with x's on either way. We further look, oh, okay. It seems to be there's an optional parameter here where I can give it a different fill character if I want. This is saying, you'll talk a little bit more about this when you do objects, but you can have named parameters. So this sort of says, the user can pass this or not. If the user doesn't pass me a third parameter, I'm just going to assume it's the default space in this case. But I can always say, oh, center spam in 10, and then use this as a fill parameter. And then we've solved the problem just by reading through the documentation properly and utilizing the correct method, which I say is a totally fine strategy. Now, I caution you about, I've seen a lot of answers on EdSTEM that solve sort of the midterm problems using methods. It's like, fine, but are you really going to memorize hundreds of methods for your midterm examination? You don't have a cheat sheet. So just be careful if you're relying on using string methods to do everything, because you're going to have to remember how they work. Whereas someone who just understands like 3 things about strings, they're indexed, they can be sliced, and they're ordered, will be able to do everything, right? So that's why I love computer science. I'm terrible at remembering everything. I only have to remember a handful of things to do everything. And it feels very empowering. This is an exceedingly useful string method that we're going to use all the time, especially in file processing. So the second part of this lecture, we're going to read in from files, which means we're going to read in a string line by line. There's a very popular type of file called a CSV. That's like any type of spreadsheet that you download is going to be in its raw form, a comma-separated value. And this is going to give us a lot of leverage for actually taking input and breaking it into pieces. Like, so for example, I can type A space B space C, and if I split that, we're going to get a list back comprised of everything. It's going to separate all of the words, so to speak, right? Ignoring their spaces. So you could take a sentence, for example, and split it and get the words back. So that's pretty useful. If you split on this, you're just going to get the same thing back, right? So obviously, if we look at what would we guess default split is acting on? Spaces, right? So if I look on help on string.split, oops, maybe get, okay. Where is it? Okay, so give me a string and then give me a separator. And then I will give you back the string split upon that separator. If we can't do it, you're going to get a negative 1. I didn't actually know that. Okay, so I can give it the optional parameter. I can say, oh, actually split on X. And what this is going to do, it's going to treat the X as the separator of your words. I can say split on not just words of length 1, but like arbitrary strings here. I can say split on BX. So it's going to use this as the separator of words. So we're going to get AX and C back. So again, very importantly, if you have a line that's extracted from a comma-separated value file, you can very now easily say, oh, split this string on the comma and get that back. Now, what does anyone see a problem with what just happened here? Yes, miss. Yeah, look, there's spaces here. I don't want those spaces. Is there any way that I could fix this? Yes. Let's split on comma, space comma instead. I want to use that as the separator of the things, right? So splitting on comma space actually gives you sort of more sanitized type of output. So this is very important, right? Because the philosophy from reading from files is to grab one line of the file and then process it somehow, which usually means we have to disassemble the line somehow. So we're going to get a lot of leverage out of that one. You can also do the opposite, right? So given a list of strings, if you want to sort of glue all those strings together with some connective tissue, that's what join's going to do. I always sort of screw this up because I always sort of I always give it the list and say join on comma, where it's in fact the opposite of that. So it's sort of saying with this as glue, join the interior of this list. So out of here, you're going to get A comma B comma C comma C, right? So this is what we'd want to do if we had data in a list and we wanted to write that list to a file. We would say join it, make it this string, and then push it to the file. If I joined on empty space, actually, you're just going to concatenate. And if you join on comma space, you're going to generate a proper comma separated line, right, for your CSV file. So, oh, and of course, we can join on any types of strings that we wanted. So you can get A, XXXB, XXXC, right? So split and join, exceedingly useful. Like those two you should have in your pocket for sure when dealing with files. Okay, so sometimes data types come with extra functionality by way of methods, right? So you can always type help into the system to see the documentation for any of the methods or types that you're utilizing. We're running programming competitions at the moment in Python, and you're barred from utilizing anything but the REPL, right? So the only way that these students during these competitions can get any help is by accessing the documentation. So this is a skill set that you really do need. Oh, we're not going to do dictionaries next. Next, we're going to do file I/O. So I don't know why that says dictionary. So is there any questions about methods? Right. So methods are something that you apply to objects. You're going to be writing a ton of custom methods quite soon. So I'll put a pin in that so I don't blow the story on object-oriented programming. Okay, let's do file I/O now. Okay. So we talk a little bit more about the memory model because this is becoming lost. So this was the memory on my 2016 MacBook Pro when I was teaching at the University of Toronto. You have we talked a little bit about how memory was like literally physically on-off switches that are on your computer that could be toggled into on-off positions. And that's what we sort of conceptualized saving something would be. The memory model is a little bit more complicated than this. There are various levels of memory in your computer because so we talked about how your computer can do billions upon billions upon billions of arithmetic operations per second. But the other thing that it needs to do is also maybe write something on a blackboard in order to facilitate that. It needs to save and it needs to read. Now, what's the point of having a computer that can do billions upon billions of computations per second if any communication that it has to do takes days? Okay, so like it's a twofold problem here. It's not good enough for a computer to be fast computationally. We're also concerned about its read-write speeds, its spatial complexity. Now, the way that this works is that there's the processor on your computer, and then like right beside it, like because proximity to the processor is going to matter because we're moving along around electrons. There's something called the cache. And this cache is all leveled. And the cache is like the fastest memory that your computer has access to. like almost immediate. But it's very expensive to make, and it's not very big. 256 kilobytes is a nothing amount of memory. It's like a nominal amount of memory. So the processor gets access to that. If it needs more, it has to go to the L3 cache, which is sort of like, it can almost hold a third of one of the pictures that you take with your phone. But again, it's very fast. If you need more memory than that, you move to random access memory, or what's called your RAM. On my computer, this was about 16 gigabytes. And this is where Python gets executed. Right, so when you run a Python program, it gets allocated space in your RAM, and it's actually possible to like exceed that space. Right, so what we need to do is now get Python to say, oh, I can't fit in here, so I have to utilize this now, the disk level, right? So above the RAM on your computer, you have your hard disk, the things where stuff gets saved. And the important thing about saving there is that there's a lot of it. And then if you move from the disk to the cloud, there's like a functionally infinite amount of data here. Now, when I was a graduate student, I was doing scientific computation. So I had access to some of Canada's fastest supercomputers. I had to get special permission to run my software on a computer with 16 gigabytes of RAM. That wasn't even that long ago. So I always ask this question. Who has 32 gigabytes of RAM on their machine in front of them? How about 64 gigabytes of RAM? 128? Someone last year had 128 gigabytes of RAM on their machine, which was like a nonsense amount of RAM to have. But you should know, like the memory is getting better as fast as the processors are getting better. Does anyone know why this is called random access memory? Yeah. Yeah, exactly. Okay, so a little bit about the memory model. So this disk is so big because when we manufacture it, we basically just create a bunch of wafers and then stack those wafers on top of one another. That's why your disks are round and they spin. And what we do is we like send a read head onto those wafers to try to search for information. So that is to say, at least with a conventional hard drive, you have to look for stuff. Where in random access memory, it just says, oh no, you get to like just basically point anywhere you want and we'll give you access to that bit of memory. That is to say, access to the memory positions are randomized. So it's a little bit good to know. You're going to learn a lot more about this memory model as you move up, because the one thing that Python doesn't obligate you to do is manage memory, which is what you have to do in C and Java. So I make the analogy here. It's like you're all learning how to drive a car. And Python is like driving the automatic car, and programming in C is like driving a manual car. So it's good to learn how to drive and steer before we then next obligate you to sort of do the shifting, right? Which is like memory management. Does anyone here know how to drive a manual? I'm driving manual. Oh, good on you. Good on you, everyone. Okay, so the other thing relevant about these types of pieces of memory is their persistence. So in order for the cache and the random access memory to remember anything, you need to give them electricity. If you're running a Python program and you cut the power to your computer, your Python program is lost forever. Okay, so we may also want to actually save results of our Python programs to the computer in such a way that they're remembered. Right, so the two problems here are this, that we may want to use, like, suppose we want to process tweets or X's, what used to be called tweets. How many tweets do you suppose there are for us to process? Minimum terabytes of info, like thousands of gigabytes. So do you think we could write a Python program to count the number of times Taylor Swift shows up in a tweet? Do you think that would be impossible? Shouldn't be impossible, but do you think it's possible to say, okay, as the first step of this Python program, load all tweets that have ever been made into RAM? Exactly. That is the correct response, right? No, it's not going to be possible, right? So does this mean to say we can't solve that problem? No, right? We just need to learn how to utilize the higher levels of memory. Right, but this is going to be important with our philosophy of working with files, because a lot of intro programmers will load a file into RAM in its entirety, which is totally wrong. Okay, so we're going to limit ourselves to files by accessing them line by line, right? Because the whole point of this is we're going to be utilizing data that can't fit in RAM. And the secondary consideration is that we want to be able to save the results of our program sometimes in persistent memory, right? So what we have to learn today is how to interface between the random access memory and the disk memory. I have to learn how to how to let this read from here, and how to let this write to here if you want. Okay, so when Python launches, it gets allocated space in RAM, which is possible to fill up. Eventually, you're going to do this. So this is a problem if we want to solve memory-intensive problems. We may also want to save our data with persistence. In either case, it's necessary to instruct Python to use the disk memory, one level up from its RAM. So here is a file, okay, and it's going to be on my computer, and it's going to be called hello.txt. I think we'll go, why did that move? Okay, so here we go. We're going to have to talk about directories a bit too, but you can see, here's my file system over here. I have in a folder called data, a file called hello, and this is what's inside the file. 4 lines. What a wonderful hello world. Oh, it's a little bit different than that one, but it's philosophically the same. Okay, I'm just going to draw in the line endings here because they're going to become important. You normally don't see this unless you've instructed your IDE to actually display hidden characters. So we're going to be able to, okay, so here's the imperative to now access a file. And I have to give you a huge warning here. This is the first operation that I'm going to give you that can actually ruin something on your computer forever. If you write a file, Python will create a new file. And whatever file used to exist with that name is gone. I don't want to say deleted because that would then imply it's in your recycling bin. It's gone. Okay, so be careful when using files for writing. You may actually destroy something on your computer that you need. So that's your warning. Okay, we'll talk a little bit more about writing. We'll start with reading. Reading is much safer. Now, you should get more comfortable with this because as you move through the computer science curriculum, we're going to give you more and more access to your computer, period. And it is possible to instruct your computer to do something self-destructive. It's not a robot. Asimov's laws aren't like implemented on your computer. I've seen things blown up. So just if you're working with files, it's not a bad idea to duplicate your directory and do your work somewhere else in case something disappears. The other relevant thing is you have to be able to tell Python where to find your file. And the fact that we have file systems on our computers have sort of become lost, right? Because there is no file system on your iPhone, for example. So you can use the operating system library to actually be told where Python is looking for files. Because in its natural state, if I just say file, open the file with this name, and we'll just say for reading, that will be the mode, it's going to look in the current working directory as its starting point. And we'll flesh that out. But the modes that we can utilize here are read, write, and append. Read is safe. Appending is safe. Writing can be destructive. Appending means write to a file, but to the end of the file. It'll just continue. It'll just add. You can sort of put garbage in your file, but the stuff won't get deleted. Okay, so first things first. Okay, so I want to read a file maybe. Okay, so I'll just get rid of this. Okay, so I have a file. It's called Sandbox. It's living on my desktop right there. I'm not sure that this will be visible in the YouTube, but whatever. Okay, so there's Sandbox. It's on my desktop, and there is a folder called Data also on my desktop. For those of you following along on YouTube, these are the files on my desktop. One of the things on my desktop is a directory called Data. In that directory are some files that we're going to read. And there's the Sandbox file that will maybe be writing into. But for the moment, I'm just going to start typing into the REPL. So I'm going to import my operating system library. I'm going to say operating system, get my current working directory. Tell me where Python is looking for stuff. And it's saying, I'm looking for stuff here on the desktop. That's a good sign. So I can say, okay. So what I want you to do is open a file. And the file is in this folder called data. And the file's name is hello.txt. And I want to open this for reading. And I'm just going to give it a name. Foo. File pointer. Okay. So there you go. It's open that file for reading. Now, if I did this and I didn't tell it was in that directory, it's saying, I can't find this. Where is this? If I did this, it's saying, I'm expecting that hello is on the desktop somewhere. It's not on the desktop, right? So the current working directory is telling you your sort of starting point. We sometimes call this the root of where you're starting to search. But the most simplest thing to do is simply, if you have your file, it's called sandbox, just make sure your files are like right in beside it effectively, and then everything will be searching in the same space. Okay, so suppose I've opened this file for reading. I can now use the method, which we've just talked about, which is going to read one line from that file. So we're going to get what A, and we're also going to read the new line because that was there. Like when we type this into a file, where's hello? Whoops. The only way for these to be on new lines is for me to hit enter. And if I hit enter, there's going to be a carriage return at the end of that that's sort of invisible to us. So remember, that's why I sort of put those there to emphasize that. And there's not one on the last line because otherwise there would be a fourth line here. That's also important. Okay, so we're going to read one of the lines and we're going to get what a new line. I can read a line again and get wonderful new line. I'm going to read a line again and it's going to say hello world with no new line. And so note the lack of the new line character. So we could utilize the fact that this doesn't have a new line character to actually designate this as the final line of the file if we wanted. But the question is, what's going to happen if I now ask for another line from this file? And it's sort of one of these tricky questions where it's like, we don't know. Look at the documentation and it will tell us. So maybe I'll rephrase my question and say, what options would we have here when programming this? What would be some sensible behaviors now? Yes. Go back to the start of the file, maybe. Sure. But then it would be really hard to know when we're ever at the end of the file. Yes, sir. I don't like that at all. That's like the Fortran philosophy. My colleague over there said return garbage. Okay, that's technically possible. Yeah. Anyone else want to venture a guess? Yes, sir. Return the empty string. Yeah. Or EOF is a special symbol that's actually, I think, in the Unicode or ASCII table. So if you're programming in C, C would return EOF, end of file. One more guess. Yes, sir. Arrow would also be very sensible, something like no more lines to read. What we actually do get here is an empty string. And we're going to get empty string for forever. Right? So once you read the last line of a file, what remains to be read is empty string for forever. That was the decision made by the people who implemented this. Not to say that any of the other choices were bad, except maybe the garbage returning one, because that's the Fortran philosophy. Okay, I was saying that for loops are my favorite structure for Python programming because it lets us enumerate through anything that's sort of walkable. Now, a file seems like something that should be walkable. First line, second line, third line, fourth line, fifth line. So it shouldn't be a surprise that I can actually utilize these files in a for loop. And you can get a very nice statement like this. I can say, okay, open the file, and then for a line in the file, print it. Right? So effectively, a for loop is going to let you process a file line by line in a very compact way. We're going to get what a wonderful hello world. Now, notice that we're getting extra prints here because remember, when we extract this line from the file, it has a new line there. And print also adds a new line. Right? So maybe that was a nuance that we perhaps forgot. So if I say print ABC, but with a new line, right? That's why that line is being put there. Right? Whereas if I were to print without this, right, then you just get one line. So that's why those are there. I colored those line endings a few slides ago to emphasize the fact that that's why those extra ones are there. Okay, so observe what. Okay, so suppose I've looped through this file in a Python program, and then I write the same loop again. I want to go through the file a second time. What do you think it's going to do? Okay, so I'll explain to you a little bit about what Python's doing with files. So it has a file, it knows where it is in memory, and it knows what line it's currently at. So whenever it for loops or reads a line, it just increments that pointer down a little bit. So once we run this for loop, where's Python pointing in the file? The very end. Where is it pointing still? The very end. So what's this for loop going to do? Nothing. Okay, because once you reach the end of the file, it's not just going to keep going back up. Okay, so if you want to iterate through a file twice, which is a bad idea, right? These things are very big. You probably should get everything you want to accomplish by passing through it once. But if you wanted to go through it again for some odd reason, what you have to do is reopen the file. And what this does it says to Python is start again, put the pointer back to the first line. And I want to do a reach reversal. So once we do this, then we can have a for loop again, and it prints everything. This is very important. You need to close your files once you're finished working with them for a variety of reasons, right? You may find some of your file is missing or extra bit in your file are garbage if you don't close afterwards, right? So whenever you're programming, if you ever open something, a file, immediately you should write the statement for closing that file. I'm going to show you the with construct, which will sort of make that not purposeful. But I'll just, we haven't done writing yet, but I'll just show you something interesting about writing. Oops. Let me get rid of that. Okay, let's see. That's my desktop. I'm going to start Python. I'm going to say, give me a file, open a file, test.dat for writing. Okay, so you're going to see it sort of materialize in here when I hit enter. Where did it go? Here. Okay, so Python actually created a new file on my desktop. Let's take a look at it. And what I'm going to be able to do is write into this file so that said, I successfully wrote 5 characters to the input buffer or output buffer. Where is my stuff? That's the file. I'm supposed to be writing to that file. Where's the stuff? Here's the answer. Doing I/O on a computer is like one of the most, how should I put this? It takes a lot of work to do I/O. And Python's lazy. And the operating system itself is lazy. When I'm saying, oh, can you go please write something to that file? The operating system goes, oh, it's a lot of work. I'm just going to wait. Because maybe you'll want me to like write a bunch of stuff to that file, and it'll be better for me to wait. So all of this stuff actually is sitting in what we call an output buffer. And it's not necessarily going to write to that file up until the point where it has to. And the point where it has to is when I close it. Then Python says, damn it, okay, I actually have to go execute all of that hard work. You may see partial results I'm not saying it's always going to be blank until you hit close. Sometimes it will show up. Sometimes it won't be there. The operating system is sort of non-deterministic in the manner it decides to actually prioritize stuff. But this is just a long way of saying, look, if you don't close your files, bad stuff is going to happen. Like my first programming job when I was in high school, I was really ashamed because I was computing something and all of it was printing to the screen fine, but I had to save it to a file and it was all mangled. So I had to go to the senior principal investigator and say, I don't know what's happening. And he said, you didn't close your file. You lied to me when you told me you're good at programming. So close your files. That's a very important thing. So how do we close a file? We just say file.close. So as soon as you have open written in your code, you should certainly have a file.close written in your code. Those two things should come simultaneously. But that being said, there's only some cases where doing it that way is necessary. We normally want to use this alternative to close called with, because it handles the opening and closing of the file safely for you. And actually anything bad that happens within a with is handled. Okay, so instead of saying file open and file close, what I can say in my code is say, oh, with open this file called hello.txt for reading as file. So that's a name that I give it. And then everything inside that with has access to the file. And once that with finishes, it closes the file for you. Right? So this is a better way of going through files. And we'll do it both ways because I'll show you the different philosophies at play here. Okay, so let's write a function, number of empty lines, that takes a file and returns the number of empty lines in that file. Okay, so here's a testing file. So garbage, empty lines, garbage. Okay, so how many empty lines do we have in this file? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, and by empty, are they really empty? What is at line 2 here? If I were to read it, Is it an empty string that I'm reading? It's a new line character, right? So really what we're counting here, the empty lines are those lines that are only comprised of a new line character. So let's see if we can go ahead and write this. Okay, I'll just move this over here. Okay, so I want to write a function called number of empty lines. And we're going to take in a file, but we're going to talk about the various ways that we can actually take in that file. And I'm going to return an integer. I'm going to say, return the number of lines in the file that contain only the new line character. E.g., they are empty lines. Well, not really empty, but sort of philosophically empty lines. Okay, so what do I want to do? So the two options here are this. So what is this? What does it mean to pass a file? That's the first thing that we have to discuss. What here should we receive? I think there are two options. Can anyone delineate what those two options are? Yes, sir. Okay, so the user can open the file and then hand me the pointer to that file. That's one option. What's the other option? Yes, sir. Yeah, they give us the name of the file and we open it. So the two options here are for working with files and functions. I obligate the user to open the file and hand it to me, or I obligate the user to hand me the file name and I open it. So you always have to designate who is the one who is going to open and close the file. Let's do it in both ways. So the first way, maybe let's do it. I'll say this is a file name. This is a string. So the first way, we're going to open it. So how do we open it? Okay, with open this file name for reading as, and we just have to give it any name. So I'm going to call it the file. And then what we're going to want to do is process the file. Okay, so we'll think about what that means. So what does this mean? So we can start sort of solving this now. Well, before we solve it, let's actually not do too much. Let's just say for line in the file. Let's just print the line. Let's not do too much, and I'll just return nothing down here. Because I don't want to do too much, because if something's not working, I want the amount of stuff that I've written to be small. Okay, so I'm going to go into Python. Okay, so I should have access to, that function. So what I'm going to say is, tell me the number of empty lines, and we're on the desktop, so I can say, okay, in test.dat. It's not going to give me the number of empty lines. It should just print the content of that file. Perfect. Okay, but there's like double the amount of empty lines because of that print. But I have proven that we've managed to open the file and process every line. Okay, so now all we have to do is something like this. The number of empty lines is 0. And then for every line in the file, if the line is equal to what? New line character, I suppose. Then what I want to do is increment the number of empty lines by 1. That seems like it works. And then return the number of empty lines. Let's see. 10? Was that what we were expecting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 11, 12, 13, 14, 15. 15. Okay, so that was the one way of doing it. The other way we can do it is insist of getting a file pointer. That requires a special type annotation, so I'll just exclude it for the time being. But so now the new philosophy here is that the user is going to open the file and pass it to us. So I'm no longer going to open the file. I guess we can just call that the file now. And then here's how that use case would look like here. Okay, so I'm saying, I have access to this number of empty lines function, but I have to open the file as a user. Okay, so I'm saying, okay, here's a file. I want to open, what did I call it? Test? Test, oops, that's a breakpoint. Test.dat, open that for reading. Okay, and then I can pass that pointer to the function, which returns its output. And since I'm a good programmer, now I close that file. Right, so these are the two sort of modes of doing things, even though technically here I wouldn't do this either. I think it'd be more appropriate to say with open test.dat for reading. Then I can, oh, geez. This is why we don't type in the REPL as the file. Then I can say number of empty lines at the file. Get 15. And all the opening and closing has been handled for us, right? So I much prefer using with to the opening and closing because you can forget how to close. All right, let's do more. So we've counted the number of empty lines. The type hint for utilizing file pointers is a little bit sort of more complicated. So it's not actually like just in the system like int or string or list would be. So if we want to use it, which we do in your assessment, so I'll do it here. We just have to gain access to it. I'm just basically saying, eventually this is going to be probably folded into the system. Type annotations didn't really fully exist until like maybe 1 or 2 years ago. So these things are going to get, I'm very confident this is just going to be in base Python soon. You just want the text.io DocString or type annotation. So I can say this is text.io. So the thing coming in is a pointer to some file which contains text in it, which is like, all files sort of contain text. Okay, suppose you want to read the numbers from a file into a list. This is an exceedingly common use case scenario. Let's do it. Okay, so I'll be a little bit more complicated this time. So I'm going to put the file one deep in a directory. It's going to have this in it. 905-684-18. This is my phone number in Canada. I don't think it exists anymore, but you could try calling it and see who picks up. It's really hard dialing phone numbers here, by the way. I'm not familiar with the patterns. And then there's like secret things like, oh, you have to dial a 0 and a 6 before everything. You have to do some witchcraft before actually dialing a number on your thing. So moving to a different country, figuring out how to phone anyone, that's a little bit stressful. Okay, so we want to read these numbers into a list. So let's do something like that. So we can say def read to list. Read to list. We'll do it both ways again. So I want to take a file. Maybe the first thing I'll take is a name of that file. And I want to return a list of integers. And what we're going to do here is return a list of numbers or of integers, which are read from the file name. Okay, something like this. So we're going to open the file since they've given us the file name. So I'm going to say open file name, with open file name for reading as, I'm just going to call it Bob, just to emphasize the fact that this is the thing that you want to call the file, Bob the file. Okay, and we always do the same thing with files. You basically want to line by line walk through them. So for a line in Bob the file, what do I want to do with this line? And so the whole objective here is to what? Return an accumulation of integers in a list. Okay, so I can say, let's start accumulating on the empty list. And eventually I want to return the thing I've accumulated, right? Accumulating is a very common pattern in programming. So what have I grabbed out of Bob the file at this point? It's this one. So I read one line. What am I holding? All right, so at line 11, what is line holding? Maybe if I do one read, what is the content of line? If I read from here. I've opened this file. I've read one line. What is in the line? Yeah. Well, okay, but this is sort of what I'm trying to get to. You said 905, but like the string 905. Okay, remember, all of these are strings because we've typed them. We don't yet know that they're numbers or not. All I know at this level is that the file contains strings, which I hope we can convert to integers, right? So if the line is an integer, then I can sort of say, okay, to the back of this append the integer version of that line, and this will work. So I can say read to list. I want you to read to list data, and was it numbers I called it? Yeah, numbers.dat. And there you go. Okay, but the problem is, what happens if there is this in here? Would this still work? This is a great midterm question. I'm reading from this file. That line is verbic. Will this function still work? It only does one thing. So is it doing that one thing properly? Line 11. Will line 11 work? Let's trace this. I've opened this file. At line 11 or at line 10, the first thing it reads is what? String 905. Can string 905 be converted to an integer? Sure, then it accumulates that. It moves to the next line, which is 684. Can 684 be converted into an integer? Okay, next line, it reads verbic. Can verbic be converted to an integer? So what happens if I run this function? What happens when I run int verbic? Yes, it will error. What number corresponds to verbic? Number 1, sir. Oh, good answer, everyone. But no, like this will clark out. This won't work, right? It's saying I've encountered a line which cannot be converted into an integer. Right, so be careful. Like we had like this actually required a precondition of sorts in order to be technically working. I had to say something like precondition. The lines of fname are all integers. Okay. Or we could have like basically said only if line is a digit, right? Then do the following. Then this will insulate us. It will skip lines that don't have digits. Whoops, but then screw everything else up. If line is a digit. Yes. I think that's still fine though. Oh, does isDigit not work on this? I should have read the manual. Aha, that's interesting. Oh, weird. Because this is very weird because I think this would be acceptable, wouldn't it be? Oh no. Okay, so that's very strict. This isDigit. Okay, so how can I correct this then? I have to kick off the new line character from each of these except for the last one. So I didn't intend for this problem to get so into the weeds. So let's change it. So we have the one where we give it the file name. Now let's do the one where we give it the file pointer, which means we're taking text IO, which means I don't need this, which means effectively that happens like this. So the new invocation then is I open the file. Oops. Oh, text IO. Right, so the new philosophy is I open the file. So open in the folder called data. There's something called numbers.dat. I want to open this for reading. I have a file. I can pass it to read to list. Oh, 21. Oh, because I didn't take that line out yet. Whoops. Everything is broken. That shouldn't be here. Go away. Okay, let's try again. Hooray, 1821. But nothing's working. Let's open this and let's read it. There it works. Because what happened before is I actually ran the function, so the file pointer was pushed down. Let's just do more examples because they're fun. So when reading from a file, we're always reading strings. Do not forget to cast your strings to a more appropriate type when necessary. So here's an answer for that question. Here's a fun one. So this is sort of like more of a like real world type of use case. So suppose like we have a CSV containing information about the popularity of bands, right? So specifically there's a band name, there's a rating of that band, and there's the number of plays in that band. Okay, so I have that file here. Boom. Okay, so the question is, I'm going to give you access to a file that's structured like this. Can you tell me who the most popular artist is by number of plays, for example? So who's the most popular artist by number of plays here? I updated this for eras. I think Taylor Swift for the Swifties has the most number of plays in this list, right? So that's going to be our usage example. So does everyone understand the problem? I have a file with this information in it, and I want to know who is the band, which band has the most number of plays from this file. Right, so we're going to have to read the file, we're going to have to process the lines, and we're going to have to sort of search through the lines to see which one has the highest number of plays. So there's a bunch of stuff that has to happen here. Okay, so let's start programming it. Best band is what I'll call it. Best band. And do we want to be given someone tell me, do you want me to open the file, or do you think we should have the user open the file? Okay, I prefer opening the file just because it makes it easier to test, because I don't have to keep typing things in. So we'll open the file. And what do we want to return here? I believe probably some string. Oh, string for the name of the band. Okay. So here we're going to return the band name from file this that has the most number of plays. Okay. So first thing first, let's open this. So let's open this file. So with open file name for reading as the file, we're just going to for loop through the file, for line in the file, which is effectively the same thing we do for any file. And just so we can start, I'm just going to print that line to confirm that we haven't done anything so far that's messed stuff up. Okay, so P3. Oops. Okay, so I want to say, what's the best band in data bands? And I think, is it .text or dat? Dat. Okay, so I've proven that we can open the file and that we can sort of process these lines one by one. Okay, so what should we do? I'm holding a line. What should we do with this line? The lines look like this. Yes. Yeah, so one of the first things I want to do is be able to get the band name, to get the number of plays, and to get the rating and to get the number of plays. Okay, so it's something like this. Okay, so let's grab this and we'll play with it a bit. And so I have a string that looks like this. Actually I have a line. It's better. That looks like this. There's my line. So I can take that line, I can split it using this sweet string method that we just found out to obtain that. And actually we can use tuple unpacking or list unpacking to say this: band, rank, plays. We got the band, we got the rank, and we got the plays. Although rank shouldn't be shouldn't be a string, and plays shouldn't be a string either. We got to convert those. But I still managed. So if we do this, at this point, band is going to hold the band name, rank is going to contain a string that holds a number, and plays is going to hold a string that holds a number. So what I should do here then is just say plays gets integer plays. Okay, so that way I've turned it into a number. Are we actually using this value for rank as part of this problem? No, so actually, since we're not utilizing it for anything, it's inappropriate to give it a name. So one of the names that we're allowed to use, the only symbol that we're allowed to use in a name is the underscore. And this is one of the places where we're going to use it for tuple unpacking. I'm basically saying, I just need this I'm not actually going to use this position. So I'm just going to sort of let it disappear. Like this is only here for a placeholder, because sometimes these IDEs get cranky. See, this is a little bit gray. The IDE is trying to say you've defined a name, you haven't used it yet, which is kind of odd. Why did you put something into a variable and then not use that variable? But in any case, I have band and plays, and now I've managed to take plays and turn it into an integer. So let's just print those two things, because again, I don't want to do too much. Band and plays, and see what spits out. Okay, so I'm going to go in. I'm going to run my function. Aha, see? What did I do wrong? Oh, we forgot to discuss something. What's the first line of the file? Yes, sir. Yeah, so this really isn't a real line. So you must have worked with like Excel or something like that, right? So this is what an Excel sheet looks like in its raw form. Like it's just getting displayed to you differently through a GUI. So what's the first row of an Excel file called? It's header. You ever heard this term? It's header information. So most CSV files are actually going to have this header information designating what the values of each of the columns are. So that one I actually want to skip. How do I skip that line? Yeah. Just read one of the lines. Great. So before I start doing the for loop, I'll just say the file, just read a line. And the consequence of doing this is Python just going to move the file pointer down one line. Right? So, and this actually is the perfect place to put an inline comment because unaware of the context here, a programmer would look and say, that's really bizarre. Why would you read a line before going into the for loop, which is the thing that's reading the lines? And it's because I want to skip the header. This is an example of a perfect inline comment. I have done something. Everyone can understand what is being done, but why are we doing it? And I've just said it's because we need to skip the first line. Okay, so now that we've skipped the first line, I should now be able to say, okay, so I've now proven to you that I can grab the band and I can grab the number of times that it was played, and it's an integer. So we've touched everything that we need to touch. We just now need to process it in some type of way. Well, what's the thing that I eventually want to do? Well, we'll turn the highest rated band. So we're going to need to sort of have a highest rated band. We have to start that at something. I don't know yet. And then sort of the highest number of plays. That also has to be something like this. So in here, effectively what I want to do is say, okay, if plays is bigger than the highest number of plays, then the highest number of plays is actually this many plays. And the highest rated band, highest rated band is actually this band. Okay, is this working yet? Almost. We just have to figure out what these values should be. What should I initially set the values to these accumulators to? Yes, sir. For which one? For plays? Okay. And what about for this one? Yeah. Yeah, it doesn't matter what we set that to. Okay, so let's study this. So effectively, if there is one band in the file, is that going to be the one that's the highest rated? Yes. Okay. So if we imagine in our heads that we're processing a file with exactly one line, this has to trigger on the first iteration. Must. We have to set line 8 and line 9 so that line 17 is guaranteed to be true the first time that we run through it. Now, you pick 0 probably because you're assuming that no band can have a 0 ranking. You're wrong because Drake's in the table. Oh, he has one play. So, huh? It's Drake. After one listening to his songs, I've deduced that he's 0 rating. Okay. You wait to see once we do lowest rated band. That's going to be a lot easier to program. Okay. There's a better value than, okay. So I like what you're basically trying to say is pick a highest rated, pick a number of plays, which is impossible. So 0 may be, I think 0 could technically be, like it is possible to play a song 0 number of times. I've played most songs 0 number of times. So maybe that would be better because this is more preposterous of a value. And this would be best, right? This is going to trigger a true comparison with any number, right? So, but any of those counted. Now, here, this could be anything. This does not matter. Right? Because the first thing it's going to do is just dump in the first band that it sees on top here. All right, so that's why I think none's appropriate. So let's see if this is working. Ta-da! Okay, let's see if we can just manipulate this. Okay, if I just say whoever Amy McDonald is, I'll just put more. Amy McDonald. Okay. So like this is a very standard example of file processing. You see how I didn't read the entire file into the system? I managed to answer this question by looking at things line by line. There is a method for files called read all lines or something like that. Don't ever use it. Don't read the file into memory. The whole point of doing this is to avoid reading the file into memory because our presumption is that it's too big to fit into RAM. Otherwise, we could have just read it in as a variable if we wanted. Okay, so the philosophy about processing files is to do it line by line, right? Don't read everything in, even though that can simplify the logic a bit for you. Okay, we do the lowest rated band now. Okay, so there's an answer. Okay, so we'll do lowest rated band, worst band. I don't really need input. We'll just do this, and we do this. Okay. Okay, perfect. That one worked. All of one complexity. Perfect. Okay, so here's a more interesting problem that you can program at home for practice, maybe. So suppose like you want to work with arbitrary comma separated values. So I'm going to give you an arbitrary CSV file. It will have some header. So suppose I give you a CSV file and it has header name, grade, and age. I want to be able to say, find me the name which corresponds to the largest grade. But I want this to be sort of arbitrary. So I'm going to give you access to a file. I'm going to say, and I'm going to give you some attributes in that file. And I want you to find the largest, like the row with that attribute that's largest. So I say, I give you path. It happens to have a header like this. The attribute I'm giving you is grade. Give me back the row with the largest grade on it. That would be a typical. This is sort of now talking about what we're doing here, organizing information into files, is exactly what you're going to be learning in databases, right? Because it's not really clear how we should store stuff in files in order to facilitate us processing them. So it's still lots of stuff to teach you. This was what we're going to do, I think, as one of the class exercises here that we're going to do in class with the next instructor is to program Sudoku. This is a really fun program to implement. And we actually had this as an assessment piece maybe a couple of years ago. And one of the things that was required of the students to write was, given a board in a text file like that looked like this, read this into something that we could actually manipulate using the Python system, right? That is, we wanted this to be a list of lists where we had integers where there are numbers, and we just put none where there was no number. I'm gonna do this, but I want to do this with, I don't have enough time to do it in two ways. I'm gonna do it with list comprehensions just to show you how like nicely list comprehensions can actually simplify accumulations. I'll give you the answer. I think is already online, but otherwise I'll put it. Okay, so let's see here. So I have a Sudoku board here. So I want to read this board in, and then I want to produce a list of lists where the list is going to be like 6, 8, 5, 1, 3, none, none, 4, 7. And I'm going to do this in like a wildly functional way, just to sort of flex a bit, but you can unwrap it. Okay, so let's do something like read board, and just give me a file name. That's fine. And I'm going to return a list of lists, and the things in the lists are going to be integers or none. Okay, that's how we sort of codify that return type. So, okay, so I want a board. That's going to look like something like this. I also want to read the file. Okay, so with open file name for reading as the file. Okay, so I want to, for a row in the file. Okay, it's going to be, okay, we're going to walk through the functional solution to this problem piece by piece. Okay, so first what I want to do is extract all lines of this file that aren't that separator line. So I'll show you how we can do that. I'm going to say, because this file is an iterator, so I can say, okay, the board is going to be a sequence of rows. For those rows in the file, if the row at 0 is not that dash, the only rows that look like this have a dash in their first position. Okay, so what this is going to do, this list comprehension should collect all of the rows that are not those. So let's just confirm that. So I can say, what did I call this? Read board, and I'm going to say it's in data boards dot dat. Oh, I didn't. Let's return the board. Okay. It's hard to sort of see. Okay. How can I structure this a bit? So in each of the, okay, there's a, okay, so hold on. I'll just do this like this. Board and board. Row in, board, row. Okay, so I've extracted all the lines of the file that are not the division line. Okay, so that's a good first step. So then the next thing I need to do is for each of these rows, okay, I need to process that row so that the numbers that I find go to numbers, and those separators things get forgotten about, and those empty lines become nones. Okay, so I'm just going to write down here like a helper function, helper. You give me a string, and I'm going to return to you back a new string. And what this is going to do is if x is a digit, then return x is as a digit. If x is this separator, then I don't want it to return. Oh, if x is a space, then I want to return none. Okay, so I just have a helper function. And again, this helper function, if given a digit, returns a digit. When given a space, returns none. Okay, so what do I want to do here? So I want to build a row. Okay, so I want to say, I want to build these rows, but it's going to be x for x in this row if x is not equal to this divider line. And then, so x at this point is either going to be a number that I've grabbed or a space. So if I send it through this helper function, there it is. Oops. I know that was a little bit of a lot to take in, but you should be able to, or we could take this and then like undo like the comprehensions into the accumulations. So this is a little fun functional programming thing, but you should try to do this one at home by like, utilizing the for statements. And I do have the answer to that, and I'll make it available to you. This is how it would look like without using list comprehensions. If I were to like take out all of the accumulators. Right, so this was a little bit tricky for me to actually program not using the comprehensions. So I do encourage you to use the comprehensions. Okay, let's get moving a little bit more. So another one that you could write, so is has one, right? So if I give you this board that's been read, could you actually tell me if the board is a winning configuration? That was an assessment item. Writing to files. Okay, so you can read from files. You also want to write to files. This is going to be necessary if you want to like remember information from run to run. The only thing that you have to note here is that we can open a file for writing, and that comes with all of the warnings that I've been saying. If you open something for writing, the file is going to be created, and any file with the same name that's living in the same place is gone forever. Right, so don't overwrite something that's very important to you, because there's nothing that we can do to help you recover it. You should note that you can write a single string to a file by doing this. It's like by giving it a string, or you can put a bunch of strings into a list, and then you can write all of those things simultaneously. So this is going to sort of have an embedded for loop for you, where it writes every component of this list to the file as a single line. So, but be careful. Opening a file for writing will create the numbers.dat file, or overwrite the old one if it exists, which is equivalent to actually deleting it. Appending is safer than writing. You can always append. The difference here is that append won't create a new file if not one file exists. I'm not actually too sure about that. Let me just confirm that this is the case. So this is my desktop. Okay, let's see if I open test data.dat for appending. Will that create a new file? Oh yeah, it did. Okay, so both will create new files if no file exists, but with append, if a file exists, it won't delete it. What's there? It will only add to the end of the file. Right, so you probably should be appending unless you really want to be writing into new files, but just keep that in mind. So we can read strings from files, we can write string to files, and a file pointer is moved down the list of the file each time that we sort of call read lines or do a for loop. Okay, so we're going to be doing a lot of string processing soon, and think how we could eventually implement that Sudoku example, because maybe I should show you this. Like we used to do sort of more fun stuff We used to program games in this class. Oh, maybe after class. I'm sort of running out of time. Okay, so what I want to finish with today is just a quick talk about testing and debugging. So testing. DocString testing specifically. Now, this whole time, we've been obligating everyone, perhaps painfully, to write DocString tests. Okay, so normally we'd write something like return the factorial of x, that is x factorial. And I said, oh, okay, so give some usage examples here, just so people know how this works. Now, we're actually able to utilize this for testing, automated testing, if we're doing it properly. So that's one of the reasons we've been forcing you to put these here, because now I'm going to tell you the command to run to actually get Python to verify it, right? So all of your code that you've written up to this point, you've written in testing for, right? If you just maybe haven't realized it yet. Okay, so I'm going to implement a really bad factorial function so we can test it until it starts working. So I'll say, okay, I have an answer. It starts from 0. I want to return this answer maybe, and then 4K in answer, sorry, range answer. I want to say answer times equal to K. Okay, so this is very close to a working, this has all of the pieces of a working factorial function, but it's broken, right? This is not going to work. So let's see. I'm going to read this in to Python. Oops, I'm in the wrong place. Let's get back all of those answers so I can send them to you. Okay. Okay, so I should have access to this factorial function. So I can say import test module. And from the test module, oh, doc test. Import the doc tester. And from the doc test, test my modules. And what this is going to do now is search all of your functions, doc strings, for things that look like this, and then run the function, and then confirm that the function's output string matches the output that you wrote. So this is going to say, I failed all cases. I was expecting from factorial of 3 to get a 6, and you gave me a 0. From factorial of 0, I was expecting a 1, and I got a 0. Okay, so how can I fix this? Yes. How can I fix this? By not substituting it with a totally different implementation that's recursive, right? Okay, I'm accumulating on answer, right, by multiplying it. Should I start multiplying 0 by stuff? No, okay, so that's one thing. And the other thing that we can do now is I can say if, you've seen this in some of your tutorials, if name is equal to main, import doc test. So this is basically what will run if you just call Python on this file. And what I wanted to do is just run doc test, okay? And so now what I can do is just say Python run on this file, and you're going to alert me if there's anything wrong with it, right? This is a lot faster. Okay, so I've changed that to 1. It's still not working. What else do I have to fix? What's the first member of range? 0. What's the first thing I multiply by? So what's every other value subsequent from here? How do I fix this? Yeah. Just do K plus 1, sure. Right? Because remember, this will go from 0 to x minus 1. And what we actually want to do is take 1 to x, right? So we'll just modify that by that. Okay, I run it again. Oh, still something wrong. I got a 6. Factorial of 3 expected 6, but got 1 back. What else is wrong? I would have thought that would have worked. Still wrong. Yeah. That shouldn't be answer. That should be x. Okay, so let's see. Now it works, right? So because it's not going to tell you that you've passed everything. It's only going to tell you when you failed stuff, which is what you want. If you do want to see everything, you can say set this verbose equals to true. And then every time you run this, it's going to give you a summary of what like happened and didn't happen in your system. Okay, so doing this is in fact testing. And this is good to include this when you're writing programs and to put this at the bottom of your code because you will be immediately alerted if something is not working according to the specification that you wrote. Okay, so that's the mechanism by which now you can ask if your functions are performing the way that they're supposed to, but that's only half the story. Okay, so we've corrected it. How many tests do we have to write before we're positive the thing that we've implemented is working correctly? There is no, oh, go ahead, yeah. No, I don't think there is an answer to ever to that question. I don't think, well, okay, with some caveats. Like if you know, if you wrote a function that it works on the bools, it is possible to comprehensively check every input and output configuration of your function to make sure that it's absolutely working. But that's typically not the case. So it is not possible to test your functions adequately enough, generally speaking, so that we're positive that they work. Software verification is a different branch of computer science. We can come up with mathematical proofs that software works, but we cannot accomplish this through testing. Okay, so now a better question is, well, what tests then? Like what does a good testing apparatus look like? What does it cover? What does it not cover? So for our factorial question, are these tests different? Are they testing different stuff fundamentally? Yeah, factorial of 3 is what I'd call sort of like the usual typical case. Factorial of 0 is a special case. So you do want to get that included. Would this be a good test? Like if I did factor 4 then factor 5, is that really helping at all? Not really, because those are all redundant. Like you're not, if factorial of 10 works, probably factorial of 11 works. Okay, so here's the guidance for trying to get good coverage on tests. And I'm not, we really can't tell you how to do this like with a recipe. Like testing is sort of an art. You can get hired at companies, a quality assurance analyst, right? There are people whose specific jobs are coming up with good tests. Yeah. Yes. So the question was, shouldn't we choose negative numbers here in the test? But I'm just being lazy. Like this technically had a precondition that said x is greater than 0 because factorial isn't defined for negative numbers. But this is a good conversation. Should I now have tests here checking for negative numbers? I always get asked this question by novice programmers who are like, oh, well, we should do tests for when x is a negative and when x is a string and when x is a list. It's like, how many ways can x not be an integer? A lot of different ways. Are you going to check all of them? So in testing, you're not checking for that the contract has been satisfied. We're always assuming that the contract has been satisfied. If you don't pass me the input of the correct type, we're no longer playing this game. Okay, so testing is checking for correctness of the function under the precondition and assumption that you've been given all of the right stuff. That satisfies typing preconditions and that satisfies normal preconditions. So it'd be, the other thing is, what would I even put in as a test for -1 here? Runs forever, like computer is going to go to the heat death of the universe. So, okay, so here's sort of like what you sort of want to try and cover when doing tests. So you want to test typical cases, a few of them, like how you would think that the function is going to be called like 90% of the time. So in like factorial, maybe fact of 3 and maybe fact like, I don't know, 55 or something like that. You also want to test edge cases. And the reason we call these edges is because your types basically collect a bunch of data. And there could be the smallest thing in that data. So for example, if you're working with like the integers, 0 seems kind of special. So that's an edge. If you're working with lists, the empty list seems kind of special. So that's what we call an edge. It's at the edge. Like if you were to order these things by size, it's literally at the edge of that ordering. If you have strings, you want to check like the empty string, right? Because that is a weird exotic example, right? So a lot of the testing that we write are trying to induce like really exotic settings. right? Your programs will typically work in their typical case. They'll typically be bugged in weird cases, right? So when you're writing your assessment, you should ask like, oh, did I actually account for like empty string here? Or other things like that, right? Because you may get knocked back by some. The hidden tests that we're going to give you are basically exotic tests that we're sort of expecting you guys to sort of think through. So do be careful of that. So typical cases and edge cases, you want to test the zero of the data type normally. So something like zero or empty string or empty list, maybe singletons or something that you should be checking, like the units, like one is kind of special multiplicatively. Maybe a list containing exactly one thing is kind of special. Maybe strings of exactly one character are special. And you want to check for correctness. Again, like we're not checking that the thing that is supposed to be an integer is actually an integer. We're assuming that to be the case. Now we want to know about the, like, if it's correct or not. And we don't want redundant tests, right? So this is sort of like a good doc test would look like. Really what you want to ensure is that if you look at your function, it should be the case that if you pick if you pick some random line in your function, one of your tests should execute that line, right? You should make sure that your function at some point calls every possible branch in one of the tests. And this requires that you sort of backwards engineer some of these things. You say, how do I get into this if statement? It's buried 3 down. Oh, this has to be true and this has to be true. So I'm going to put that as an example. But again, writing tests is hard. If we showed you the code that we're using to automate the testing of your homework, it's like 100 times longer. It's a way more sophisticated piece of software testing your homework than it is writing your homework. But testing is a very important part of computer science. There's an approach called test-driven development. It's exceedingly difficult to write software that's working. So you have to sort of be humble and start off with the perspective that like, I'm probably going to program something wrong. I should assume that the things I'm programming are wrong, and I should create tests that prevent me from doing that wrong thing. So in test-driven development, you start with the tests and then you write the code, because there's perils about writing the code and then writing your tests. Don't ever do this. Don't ever write code and then create your doc tests by giving your code input and grabbing it. That's not testing anything, right? You're cheating. You need to think ahead of time of what your function should do, not what it's actually doing. So be careful about using these doc tests, because there's some nuances here, because what we're doing is comparing this. We're comparing strings with other strings. We're not comparing values with other values. And I can sort of make my point with one usage example here, okay? How should I compare this? No, I had an example here. Oh, it's sort of like, was it int 3? Choose. Because it could be the case that something is, oh, yes, I know. Is this empty list equal to this empty list? Yeah, Python ignores spacing mostly in its syntax. Is it the case that this string is equal to this string? No. Okay. So that's the nuance at play here. The doc tester is saying, I'm going to run this. I'm going to grab output and I'm going to hold that as a string. And then I'm going to string compare that with what comes out here. So you have to make sure that what you're putting as the outcome of your function is identical to what Python would print in that setting. So specifically, if I were to print this list, it doesn't, Python says when I print it, I'm not including any gaps. Okay, so if I wrote an identity function, right, take X, return X, this doc test would actually fail, because it's saying what I'm getting out of this identity function is that string. And that's not equal to that string, even though as values, they are equal. And we do both in testing. We do both string testing and value testing. It's just sometimes to do the value testing is sort of not meaningful, right? Sometimes it only makes sense to test the strings, and sometimes the opposite is true. Okay, so again, you have to make sure that what's coming out of your function is identically string written to what is in there. You also have to be careful with using lists. When a list prints, it actually creates tailing space after a comma. It's good styling. But you don't have to put it in when programming, but when you print the list, it certainly does get included, right? So you do have to include those spaces there for this doc test to come back as true. And otherwise, you'll get a very bizarre statement. Let me see if I can put it here. Okay. Let's see. Whoops, I still want the thing on the bottom. Okay, so I'm going to say, let's define my identity function. It takes X. It just returns X. Could not be more simple. So here's our doc examples. So I can say ident of 1, 2, 3 should return 1, 2, 3. And these can induce really frustrating error messages because it's saying, hey, I was expecting this, and I got this. Right? I think now that we've done some programming, you can now identify those two things as being different. But when we first started, that was like very cryptic because these things like are seemingly identical, but they're not. Like one has spaces in them, the other one's not. They are equal as values, but they're not equals as strings. So when you're outputting a string or a list like this, do make sure to include those tailing spaces. This one's going to fail for two reasons. You can't put tailing space there because that's going to be considered part of the output. So make sure there's no tailing space there. This is one of the reasons in my IDE, I make the spaces visible. Right, that's sort of helpful. And the other one is going to fail because we didn't put tailing commas after this one. Okay. So we're doing string testing, comparing printed output, and not unit testing. Oh, sorry, that's actually wrong, and not value testing. Unit testing is what we're doing. The output must match what Python outputs exactly, right? So this is sort of like a good test for that identity question. This is also going to fail, right? So although 1 is equal to 1.0, what 1.0 prints actually is going to be 1.0. Right? So do make sure you're going to have to put a 1.0 there when working with floats. So this is going to say, I expected to get a 1, but you gave me a 1.0, and those two things are not equivalent as strings. Worse yet is that when we're working with floats, that like floats are never equal to other floats. Right? You have to take whole classes about how to compute with floats because there's like a lot of baggage. So we never actually do equality testing on floats. We asked for those things to be sort of compared as a tolerance. When we compare floats, we don't say is X equal to Y. We say is X close enough to Y that it's accepted as equal. Okay, so suppose we're given a following function. How can we gain confidence in its correction through black box testing? So that is to say, all I tell you, I'm just going to give you a function and tell you how it works. I'm going to tell you nothing about how it's implemented. And I just want you to tell me how many tests you think are necessary for us to gain confidence that this is actually working. So here's a power function. I've programmed it recursively in an attempt to try to obscure its meaning, right? So this computes the power function. You don't have to understand it. That's sort of the point. Okay, so suppose that you don't believe me that this is going to work. How many tests do you think that we should do here? Well, in the interest of time, we'll just sort of, so this is going to do X to the Y. We have a precondition that Y has to be bigger. So sort of here's maybe I don't know if this is all the coverage, but certainly this is what I would expect to be included, right? You need to check zeros and 0 to the 0 and maybe 1 to the 0 and maybe 0 to the 1. So 0, unit and 0, 0 and unit, a typical case with a unit with a typical case, and a typical case, right? So even for something as simple as power, the number of test cases is going to be multiplicatively higher for every input that you have, because now you have to sort of make sure that like, oh, all of them can be 0, one of them can be 0, some of them can be 0, some of them are 0, some of them are units. Right, so there really is no special sauce or like recipe for developing all of these tests, but the more the better up until the point where you're adding redundant, I guess is the general philosophy here. Here's something that you can do at home. Just write some doc test for this simple function, which returns the larger of X and Y. Some other nuances in Python that are going to be relevant for doc testing is that sets will print out ordered only when you put numbers in them. So if you type in 3, 2, 1, the set, even though that it's unordered, you get back an ordered set. This isn't true for anything that's not a number. I don't even actually know why it chose to print out C, B, then A in this setting. It's sort of unknowable, right? So how then are we supposed to test strings? Well, anything that you put here actually is just any valid Python command. It doesn't have to be only a function call. So I can say, oh, out of identity, I expect you to be value equal to that set. And then when you value equal that set, the outcome I expect in this case is true. So this is sort of how you can hack value testing into the doc tester by just basically saying, oh, this is the thing that I actually expect to come out of you as a value, right? And it should be true when you compare to that. Because dictionaries are also unordered, we also have to do dictionary comparisons like this because we don't know what Python is going to spit out when it does that dictionary. Like I know it happens in sort of the order that you create them, but we don't know how the dictionary was created. The following is also allowed. Like you can have like arbitrary Python code. I can say A gets assigned 2 and then B gets assigned 1 and then do identity A plus B. So frankly, anything that you're putting in here as a doc tester, you can just treat as like basically a Python session as you want. And it's just going to make sure that the output of that Python session has been validated. This one's good because this comes up with so many edge cases. So you're all taking calculus or should have taken calculus. You know what a parabola is? If I were to ask you, find me the lowest point of this parabola, you can do it, right? You just have to take the derivative and find a critical point, blah, blah, blah. So here's a function that I'm going to say, you give me A, B, and C, and I want you to tell me what the minimum value on this parabola is, except there's baggage. What if A is 0? Now it's a line and a bunch of other stuff, right? So this is actually going to induce a lot of edge cases. So this is a good one to go through. You just need to know, so we don't actually compare floats. So I'm going to say, we're going to have some tolerance. And if the thing that comes out of this function is close enough to 0, then we'll accept it as being equal, right? So when you're dealing with floats, do not do equality testing. You have to do sort of ask if two things are close enough. If you're you don't really have to do this in a DocString. You could actually put, you could take a DocString and put that into a file. Just don't include the triple quotes around it. And that file can be as big as you want. And then you can just instruct the doc tester to like test from that file if you want. It looks something like this. I want you to doc test, but the tests are in a file, and it's called this file, and maybe sort of give me output. The last thing that I want to talk about is assertions, because these are becoming more popular. I think I've been this is blown up on the socials. I think I saw Lex Friedman talking about assertions, but I use these a lot. We use this a lot in mathematical computation, because when we're doing mathematical computation at any given time, I know something is true about the code that I'm working with. So an assertion is a truth claim that we can have and that Python can be told to enforce. So programming with assertions can help you catch problems by preventing them. Well, not really preventing them, but if the problem occurs, Python is going to say, hey, you violated an assertion. You said something should be true at this point, and it's not. So something probably has been coded wrong. If an assertion has failed, Python raises an assertion error. So I'm just going to give you a couple examples of where you can utilize this. And sort of the more the better, because we can turn them off if we want. I can always tell Python, ignore all the assertions, so we don't have to pay a sort of performance penalty for including them. But here's a good one, right? So I can have the factorial function, and the last line of my function, I can say, assert that the answer is positive. I know that this factorial function can never return 0 or negative numbers. That is knowable. Therefore, if we reach line 5 and answer is negative, something is wrong. Something is wrong. And Python is going to say, I'll ask for is this the one that's wrong? Yeah, this is an incorrectly defined factorial function, because it's going to sort of say that that's 0. So if I run factorial of 3, it's going to say there's an assertion error. You said something was supposed to be true at a given point, and it's not. And the other thing is that's not the only thing you're going to see. You're going to see a lot better information. It's going to say, hey, you failed an assertion in this file at this line. So it even says, go to this part of your file, and that's where you should start looking for the violation of that assertion. This is something that I use all the time when I worked at Maple. So I prefer short-circuiting out of functions using this return. But then it's sort of weird, right? Because in Python, if I screwed this if statement up and it got to the end of this function, it would return none. Whereas I was expecting it to return a number. And that would be a really problematic bug to find. Something that's supposed to be returning a number is returning none. How am I supposed to find that? So when I have something like this, where I'm certain that the thing, well, I know I programmed this with the intention that I should never actually reach line 7. So I usually put this in my code. If I write something with a short circuit like this, I'm saying, I wrote some code, and if you actually get here, you weren't supposed to actually, this line is not actually supposed to be reachable. So I'll just throw that in. I'll throw an assertion that's always false. because it'll just say you're not supposed to be here. Like the thing I'm trying to check at line 7 is, did we arrive here? All right, so that's why I'm always checking asserts false. So if you ever look at my deployed code in Maple, a lot of it has this like error, unreachable line. So there's a bunch of exercises that you can try at home. So write DocStrings for the following functions and then implement it, right? So do the test first and then implement it, right? So return the indices and Cs at which non-overlapping copies of sub-Cs start. So a cool pool look at 00, so you can find instances of 00 starting at index 3, not at index 4 because those are overlapping, at index 9, at index 14. Write doc test for the following function, then implement it. Insert character A after B, this character after each occurrence is B in X's. Okay, so in summary, we can verify our DocString examples using doc test. You should keep good doc examples in your code and then use this test mod to automate the running of them. Good luck on your midterm this Saturday. I will catch up with you guys week 13 for recursion. Good luck with the object-oriented programming module. Bye, chat.